Hello and welcome to another video. In this video we're going to be working on maximum score of a good subarray. And in this problem you're given an array of integers, 0 index, and an integer k. And they tell you the score of a subarray, and this is a little weird, the wording, is defined as min of nums I to j times j minus I plus 1. And so a good subarray is a subarray where k is between those, or return the maximum possible score of this subarray. And so in the first example, they say the optimal subarray is this whole thing with a min of 4, 3, 7, 4, 5, which is 3. And then the indices are 5 minus 1 plus 1. So essentially it's this subarray here. And in the second one, we have to include 0. So the optimal subarray is 0 through 4, which is this one right here, with a min of 4 and length of 5, so that should be 20. Yeah. So basically, in this problem, the way we're going to do this is we're going to figure out, like, what do we have to have, and then how do we proceed. And also note that num's nil length is 10 to the 5th, so we can't have, like, an n squared solution, so we have to have an n log n or better solution. So this is actually going to be very simple once we figure out, like, the trick to it. So let's just take some array. Like this one is fine. So let's say we have 1, 4, 3, 7, 4, 5. We can even add more numbers if we want to, like 6, 2 or something. Doesn't really matter. And let's say that our k value, so let's actually also draw out the indices here. So this is index 0, 1, 2, 3, 4, 5, 6, 7. And let's say for this array, just to make it simple, k is 3. And we have to figure out the answer. So what we know from k is a good subarray, k is between I and j, and it has to be, right? So whatever array we pick has to include k. So if we know to include k, which k is right here, what we're going to do is instead of including k, we'll just build out a subarray from k, and we're just going to pick the biggest number at every iteration. And that's going to give us the optimal solution. So, and then we're going to try it for these problems as well, but let's kind of look how that's going to work. So essentially, what's going to happen here is, let's just say we pick, like, we're going to have a left and a right. They're both going to start here. So we'll have a left and a right. We'll just draw these boundaries. They're both going to start here. So at first, our value is just going to be, k times the length of this array, and the length of this array is just one element. It's just, actually, instead of drawing left and right, we're just going to represent it with this blue line. I think it's going to make it easier. But we are going to have a value. So the value is just going to be 7, right? Length 1. So now, essentially, we can either expand it by going left or going right. And obviously, to maximize k, we're just going to want to always take the bigger value, right? Because the bigger value will have a lower minimum. So we're just going to say, like, do we want to go left or do we want to go right? And in this case, 4 is bigger than 3, so we're going to want to go right. So what's the minimum here? The minimum is 4, and the length now is 2, so then we have 8 as our length. So we have 8 now instead of 7, which is bigger, so we're going to replace this 7 with an 8. Now what do we want to take? Do we want to take the 5 or the 3? Well, obviously the 5 is better. So now we have length 3, and the minimum element is 4, so now we have 12, which is better. Now do we want to take the 6 or the 3? Obviously the 6. So now we have the minimum element is 4, and the length is 4, so now we have 16, which is better. And now we want to take the 3 or the 2. We want to take the 3. The minimum element is 3, and length 5, so we have 15. So 16 is better. So we're going to keep that. Now do we want to take the 4 or the 2? We want to take the 4, and now we have length 6, minimum element 3. We have 18. So 18 is better. So we're going to replace. Now do we want to take the 2 or the 1? We want to take the 2. So we have 2, length 7, so that's 14. So 18 is better than 14. And now we take this last one, minimum element is 1, and 18 is better. So essentially, at every point, we just figure out, like, what is the element that's going to make our array bigger. And we just always take the greedy solution where, like, we always want to take the bigger element. Because let's say there is something down the road that's better. So let's say we have something like 7, and then maybe we have, like, some big element and some small element, let's say. But after the small element is something like, or let's say, actually, let's do this. So let's say we have 20, so we have like 10 here and like 15 here. Like, no matter what, even if after this 10 we have some like good element and something, and after this we have some really bad element like 1, and we start here, we're always going to want to take the bigger one because we can always then pivot back and be like, okay, well, this one's really bad, so let's just take this one, and then let's take this one, right? So because we can pick every time what we want to take, there's never going to be a case where we don't want to just be greedy and take the biggest element. That's basically going to be the solution to this problem. So let's kind of walk through these examples and let's get these. So for this, we have 1, 4, 3, 7, 4, 5, and k equals 3. So 0, 1, 2, 3. So this is the one we have to take. Now we're just going to write out our result and value. So here we have 7. Now do we want to go left or right? We want to go right. So we have 4 times 2, which is 8. Okay, so we have 8. Now do we want to go left or right? Well, we want to go right. So we have 4 times 3, which is 12. Then we can't go right, so now we just have to keep going left. So we have 3 times 4, which is 12, which is the same. Then we have to keep going left. So we're going to take 4, and now our smallest element is 3 times 5, which is 15, which is better. And then we have to keep going left, no other way to go, and that's 1 times 6, which is 6. So we did get our optimal answer. And in this other one, let's just do that one really quick as well. So we have 5, 5, 4, 5, 4, 1, 1, 1. So we have to take this element here. So our value is going to start at 5. We're going to increase. Now we'll have 10. We're going to increase. Our smallest element is 4, length 3. We have 12. It's better. 4, length 4, 16. 4, length 5, 20. And now these are going to be worse, right? Because it's going to be 1, length 6, 1, 1, 1. So our best solution is 20, which is correct as well. So it's literally just start at the middle, or whatever k is, and expand out, and always take the biggest number first, and that's going to guaranteed give you the best result possible. So pretty straightforward. Maybe a little difficult to find, but not too bad. Like, it's reasonably straightforward once you realize I take the middle element, and then I'm just going to pick the best one every time. Okay, so now we can code it up. So we're going to have a result. It's just going to start at nums k. And then we need to keep track of like our current minimum value. So we'll start that at nums k as well. Then we have to have a left and a right. And we'll start those at k as well. And so the left and the right are going to represent like the left and right bound of our array. So now we just have to make a while loop to make sure they're both in bounds. So while left is greater than 0 or right is less than nums minus 1. And essentially the reason that left has to be greater than 0 and not equal to 0, because if left is equal to 0, then we can't go left anymore, right? And if similarly, if right is equal to length nums minus 1, we can't go left, we can't go right anymore. So we have to be able to go left or right. So if left equals 0, that means we can't go left anymore, or right is also valid, so right is less than length nums minus 1, which means we can go right, and the right value is better, so nums right plus 1, right, the next one, is greater than nums left minus 1, the previous one. So this is the case where we want to go right, so we're going to take the right value, and we're going to expand right, and we're going to update our current min to be the min of current min and the right value we just took. Similarly, this is going to be very similar on the other side, essentially. I think I screwed this up, actually. I feel like I did. Oh, right, we need an equal sign. And we don't need this. So now that we finished the left, we have to do the right. So it's going to be very similar. So we're going to go left now, and right. If we're going to go left, we're going to do left minus equals 1, and then this is basically all the same thing. So current min, except we're going to compare it to left now. And now we have to actually update our result right at the very end. So we're going to say result is the maximum of the old result and current min times the length of the array, which is going to be right minus left plus 1. And finally, we need to return it. And that's actually pretty much it. So let's see if that worked. And it did. And there we go. And I can submit this a few times, I guess, but this is basically as good as it gets for this problem. So this is going to be Like, let's go through the time and the space for this one, I guess. So for the time, this is going to be O of n, because we are just literally looping through our array one time, which is very efficient, right? Like, essentially, we're just expanding out from k until we're out of bounds on both sides. And for the space, it's going to be of 1 because we just have some variables. And yeah, it's going to do it for this problem, so hopefully you liked it. Not too bad of a hard problem, definitely a lot of harder ones this week and this month. So, but yeah, if you liked the video, please like it, and please subscribe to the channel, and I'll see you next one. Thanks for watching.